Hello and welcome everyone. My name is Kezia and I am thrilled to guide you through one of the most fundamental concepts in computer networking, the OSI model. This educational video is designed to help you build a solid understanding of how data flows across networks. So, let's dive in. So, what exactly is the OSI model, you may ask? The OSI stands for Open Systems Interconnection. At its core, it's a conceptual framework, almost like a universal architectural plan, that just shows us precisely how data travels from one device to another. This model is divided into 7 distinct layers, and each layer has a very specific, well-defined function. Why is this important? Well, this helps us to understand how our devices communicate. Secondly, the OSI model helps us to fix or troubleshoot problems when things like the internet or our apps are not working. What this does is that it will help us to have a step-by-step diagnosis approach and isolate issues at every layer so that we know exactly where the problem is rooted. And then lastly, the OSI model makes sure that all devices around the world can talk to each other, no matter which manufacturer has created them. So this is how an Apple device can communicate with an Android device. So essentially, it standardizes global communication of devices on a network. 7 layers can be a lot to remember, I know. But I have a really helpful trick that will help you to recall all from the top layer to the very bottom layer. So just remember this simple sentence. All people seem to need data processing. The all helps us to remember the application layer, which is the 7th layer. People is for the presentation layer, which is the 6th. Seam stands for the session layer, which is the 5th layer. 2 reminds us of the transport layer, which is the 4th layer. Need is for the network layer, which is the 3rd layer. Data represents the data link layer, which is the 2nd layer. And lastly, processing, which is for the physical layer, our foundational 1st layer. Since this is an educational video, I want us to just look at some of the common devices we might know and which layer they mainly work with before we dive into each layer, because this will help us to connect the ideas to the real world things. Firstly, we have a router, which helps different networks connect and send data the right way. This works at the 3rd layer, which is the network layer. And then we have a switch, which connects many devices in your local home or office network, or some might even call it a local area network. This works at the 2nd layer, which is the data link layer. And we have a hub, which is a very basic device that sends data to all its connections or sends broadcast of data. This is at the physical layer, which is layer 1. And then we have an access point, which gives you Wi-Fi so that you can connect wirelessly. This works at layer 2, the data link layer. Then we have a host, like your computer, your phone, your tablet, which sends and receives data directly. And this works throughout from layer 7 all the way down to layer 1. And lastly, we have a node, which is just any device connected to a network. So remember that a host can be a node, but not all nodes are hosts. Alrighty, so now we're going to dive into the deep stuff. We're going to start with the application layer, which is the top layer of the OSI model. And this is just like a blueprint of how devices talk to each other over a network. So what exactly is the application layer? Now, just imagine you're using an app like your email or your web browser. The application layer is the part that helps your app to connect to the network so you can send or receive data. For example, right? Let's take a real life example like sending an email. When you use an app like Outlook or Gmail, You type your message and add a subject and then hit send. The application layer steps in to take your email and package it up in a way that the network understands. And in this process, the protocol that is used, which a protocol is essentially just the rule book, right? The rule book or the protocol that is used in sending this email is the SMTP, or the Simple Mail Transfer Protocol. So what the application layer does is that it wraps your email with instructions like who's it going to and what does it contain, so that it can travel across the network to the receiver's server. So this is like putting your letter in an envelope with the right address and a stamp, ready for the network to deliver. Moving down, we have the presentation layer, which is layer 6. This is like the translator and a security guard for your data. What it does, it formats, compresses, and encrypts data, ensuring that the data is in a format that both the sender and the receiver can understand. Think of the presentation layer as the network's translator and protector. It takes the data from your apps and makes sure it's formatted, secured, or even compressed so that it's ready to travel across the internet and makes sense to the receiving device. For example, with our email example, right, that we previously used, imagine you're sending an email with a photo attachment using your Gmail. With the application layer, of which we talked about before, it handles the email itself, but the presentation layer, this is like the stylist who makes sure everything looks perfect and stays safe. How? Firstly, the presentation layer formats your photo into something universal like a JPEG so that the recipient's device can open it. Then it also uses UTF-8, a universal language for text, to encode characters like emojis or special letters so they display correctly. Next, it encrypts your email using something like TLS, which is a protocol, to keep it secure during transit. Think of it like sealing your message in a secret code. And if the photo that is attached to the email is too huge, the presentation layer will compress the photo to make the email faster to send. The session layer is our main focus, which is the 5th layer of the OSI model. This helps devices to talk to each other over a network. How it does this is that as the network's conversations manager, what it will do is that it will set up, control, and end communication sessions between devices, making sure data flows smoothly and stays organized. So what is the session layer all about? Think of it as the network's conversation manager. It sets up, controls, and ends communication sessions between devices, making sure data flows smoothly and stays organized. Just like when you're having a call and you start the call and you talk and then you hang up. Now we've come to the transport layer, which is the 4th layer. This layer's primary role is to ensure that data gets reliably from one application on a device to another specific application on a different device. Example, when you send an email using Gmail or Outlook, the upper layers that we talked about, which is the application layer and the presentation layer, create and format that message. And then the session layer is the one that manages that conversation. And then the transport layer, this one is like the delivery truck that breaks your email into smaller chunks called packets, and then ensures that they get to the email server safely and in the right order. So whether you're streaming a video, a movie, video calling on WhatsApp, or sharing files, the transport layer ensures your data arrives accurately and in the right order, using protocols like TCP for reliability or UDP for speed. Next up, we have layer 3, the network layer. This layer's main job is to find the best path for data to travel across different networks. For example, say that you want to send an email to your friend in Ghana. Now, with the previous layers, the application, presentation, and the session layer, they create, format, and manage the message. The transport layer then breaks that message into packets. The network layer, however, is like the navigator that decides how those packets get from your device to the email server, even if you are halfway across the world. But for the network layer to achieve this, it uses a protocol called the IP, or the Internet Protocol, to give each packet an address, like putting a postal code on your mail. Now, the data link layer, which is the second layer. This layer moves data between devices that are on the same local network. Data at this layer is called a frame. So, the data link layer is more like the local courier who quickly delivers your email's data from your laptop to your Wi-Fi router, making sure it gets there with no mistakes. How does this actually work? So the data link layer adds special addresses called MAC addresses to each packet. This is like a label that identifies your laptop and the router on your network. These MAC addresses ensure that the packets are sent without errors to the next device in the same network, like your Wi-Fi router. If there is an error, then the data link layer can catch it and then ask for a resend. So it's like double checking your mail before handing it off to the next courier. Phew, and now we are at the very bottom layer, which is the physical layer, layer 1 of the OSI model. To link this to our email example, the physical layer would convert your email's packet into electrical signals, light pulses, or radio waves, depending on the medium that is being used, be it Wi-Fi, fiber optics, or cables. So it transmits these signals to the next device, such as your router, your Ethernet cable, the wireless antennas, right? So think of this more like the physical road, be it you're streaming a video or you're sending an email. The physical layer will ensure that data travels as signals through the network's physical connection. We'll recap each layer's role with a helpful postal analogy shown in the table. Starting from the top, the application layer is where you compose your email in an app like Gmail, where you create the message. The protocols that are used is HTTP for web browsing or HTTPS, and SMTP for email sending. Next, the presentation layer formats your email into a standard form, like encoding text in UTF-8 or converting images in JPEG. And then it secures it with protocols like SSL or TLS, similar to translating and sealing a letter. And then the next one, we have the session layer, which sets up and manages the connection for your email, like arranging a delivery schedule with the email server using protocols like NetBIOS. And then we have the transport layer, which acts like a post office, breaking your email into packets and ensuring they arrive complete and in order with TCP or quickly with UDP. Moving down, we have the network layer, which is layer number 3. Adds IP addresses to packets and routes them across the internet to the email server, with routers guiding the way. It plans the global journey, relying on local hops. Next up is the data link layer. This one is like a local postal worker that adds MAC addresses to packets for delivery to ensure the next device, such as the Wi-Fi router, uses switches. And then lastly, the physical layer sends signals over cables or Wi-Fi, just like roads and trucks that deliver the data from one stop to another. What's life without a little bit of tests? We're going to go through a little quiz time to test your understanding. I will read out the questions, but you can also pause the video to think about your answers. Question 1. Which OSI layer handles encryption? Question 2. What protocol does the transport layer use? Or should I say protocols? Question 3. What device primarily operates at the network layer? Question 4, the last question. True or false? All nodes are hosts. Ready for the answers? Let's see how you did. Question 1. The correct answer is the presentation layer. Question 2. The transport layer uses TCP, which is for reliability, and UDP, which is for quick transportation of data. Question 3. The device that operates at the network layer is a router. Question 4. The statement, all nodes are hosts, is false. Remember that all hosts are nodes, but not all nodes are hosts. Great job! But before we wrap up, here are some key terms that I gathered that will help as they are building blocks of networking. So you can pause the video to review them. Thank you for watching, fellow tech explorers, and happy networking.